Drive for Innovation has pulled into Freescale Semiconductor in Austin, Texas. And here with me now are two Freescale's automotive gurus, if you will. Okay, so a couple of weeks ago, as you guys saw, we tore down a Volt up in Detroit, down to the board level, and we're going to report on that later this spring. You guys are all over that car. The amazing takeaway from that was the electronics design of that car is mind-bending. The board design is so sophisticated. The safety features that GM has designed into it so sophisticated. You guys have a catbird seat into what the thinking was going on there. But take us back 15, 20 years. Automotive electronics design has come a huge distance in the last 20 years. Walk us through that period of time.
Okay. Freescale, in those days, originally Motorola Semiconductor, worked way back in the 1970s on some of the first microcontrollers for automotive systems. Our priority in those days was very much on the emissions control when the first rules were coming out in the late 1970s. And as I said, we developed some of those first microcontrollers. We worked with General Motors, who we still work with today, and you saw we have a very large content in the Volt today. And over the years, we've developed a number of different solutions based on first 8-bit, then 16-bit, and now 32-bit microprocessors for engine control systems. And today, as you see, the Volt is a very high-tech solution using multi-processors.
Maybe an unfair question, but who would you say pushed innovation in automotive electronics design more? Obviously, there's joint development going on, but do you think it was pushed more from the semiconductor content side, or more from the systems level design side, from the GMs and some of those guys?
I think it's a combination of both. Obviously, it is the constant improvement in semiconductors, though, that allows the system developers and the car companies to implement all the ideas they have. So it's more a enabling technology that allows every 2 years significantly more performance capability in the semiconductors at similar pricing. That allows then that these new systems and the appropriate system developers to implement their ideas that were simply impossible on the components that were available just a few years earlier. To give you an idea, the microcontrollers Ray was talking about for engine control back just 10 years today would probably not be able to handle a window lift, just because the requirements have gone up so much from the system side, communication within the vehicle, that across the board requirements are now so high that it's the newer microcontrollers that are needed to meet those requirements. But it's a back and forth. We provide more capability, customers come up with ideas that use those, and of course have more ideas in the background that would require even more capability from us, which we then urgently work on to give them in the next generation.
So in any electronic application area, if you look at its history, there always seems to be at least one and usually multiple inflection points where certain technological innovation comes together at the right time, right? In cell phones, it was Moore's Law plus software plus wireless capability. Is there anything like that that's gone on in the last 10 years in automotive electronics design?
Okay, I think there's actually, there's something just about to happen, and there is a big change in technology that happened, and it's actually more than 10 years ago. One of the main capabilities in semiconductor technology that has helped automotive is the development in the late 1990s of embedded flash memory on microcontrollers that could support very high operating temperatures. So a lot of engine control, and the majority, is under the hood, and some of it's actually bolted to the side of the engine. So that technology came about in the late 1990s, and that has now grown. Originally there were small amounts of memory. Now there are many megabytes of flash memory that are integrated into those microcontrollers. And that was a capability that allowed the systems to be integrated and appear in many, many more systems. Before that, it would have been a very expensive solution to try and do that. Now, the latest technology innovation that's coming on for automotive is the implementation of functional safety inside the microcontrollers themselves. And that's going to see a lot of the systems that require safety, such as the steer-by-wire, drive-by-wire, shift-by-wire systems, become feasible at an economic position or price for the car companies.
So, and that's embedded in the controllers themselves?
Yes.
Because you have memory?
So no. Originally, it's to do with some new architectures that are coming out, which allow redundant memory systems and redundant architectural systems, and that's just becoming possible because of architectural improvements, but also by the new technology that allows higher integration.
Okay, so you guys are in the microcontroller space. Talk to us about what. Let's just riff on that a little bit. What consumers can expect to see coming out in the next 3 to 5 years in terms of safety, in terms of navigation, in terms of drivability?
In the major areas in automotive, we see all areas actually interesting innovation, but you mentioned two as the most interesting ones. One is in the safety area, where we see a move from the classical safety systems that mitigate damage once you have an crash, for example, airbag, right, which after you have a crash, it deploys and saves your life. More and more, we're seeing the customers moving to systems that prevent the crash. Driver assistance systems that give you warning, right? Lane departure warning, for example. And over time, this will move into systems that will actually actively intervene in your driving to prevent an accident. So we're seeing the move from these passive safety systems to active safety systems, driven by the tremendously higher computing performance we now make available to our customers. Many of these systems are similar to systems that were deployed in the military, right? Radar vision systems. Now, with the cost point is getting to a point where it can be deployed in regular cars. So I think that's one really interesting change we'll see in cars over the next few years as these systems get deployed. Another one is, as you mentioned, in the driver information and or entertainment area, where we see a massive shift from the classical AM, FM radio with CD player and cassette player to much more of a connected system where you get your entertainment, be it music, right, or other forms of entertainment over a connection to the web, and you have more of a connected radio, if you will, that allows you to have access to what you would have access to from at home, just from in your car.
Let's talk a little bit about autonomous vehicles, because we can effectively do that, right? And it's going to become cheaper, more efficient, and cooler in the coming years. We know that for a fact. But it seems to me you run into a regulatory issue, right? You have governments that are not really going to be crazy about autonomous vehicles going around the world. Do you think we'll ever get there in the next few years? Or is that going to be the barrier? It's not going to be an innovation barrier, it's going to be a regulation barrier.
No, I think the ability to do autonomous vehicles is, I wouldn't say it's quite there today. I think it is something for the near future. But if you look at some of the systems that are out there for active radar systems and active cruise controls, there is a degree of autonomous vehicle there, the automatic parking systems as well. I just think it's going to be a little bit longer in technology before all the systems would be there to allow a vehicle to truly drive autonomously. And then you're right, I mean, there's a whole set of regulation items that would come along there. I think eventually it's possible, but I think there's a few years before the technology is quite there to do it. And Peter, you get any?
Yes, this will happen gradually, right? You'll get warnings about things that are starting to be dangerous, right? That you're approaching the vehicle in front of you too fast compared to your braking ability, right? So you get a warning, whatever forms, I don't know, shaking wheel or some horn or something. And then gradually, as these systems get tested out and there's experience on the road with them, and there's confidence now that they work in sufficiently high percentage of the cases, then you'll see the system starting to actually intervene. So it won't be from one day to the next you get into a car and can drive itself. No, it'll be the car can help you in emergency cases slow down before you even step on the brake because it knows it's getting too close. It'll steer you to the center of the lane even if you let go of the steering wheel. So it'll be gradually, it'll be sort of here a little bit, there a little bit, that will be introduced, and then over time, in my opinion, at some point you'll be at a point, oh my God, you can actually let go of the steering wheel and it'll get to where I want to. However, then we get these regulatory questions. What is allowed now? Are you actually allowed to let go of the steering wheel, or do you need to pay attention? Can you read something in parallel? So, but when we get there, we'll see those. But I think this gradual introduction, that will almost certainly happen over the next 5-10 years.
What are you guys dying to have put in your cars that you know is coming just down the road? What feature?
I think I do the fully active cruise control. I think it is attractive. One of the technologies that I think I really want to see is the full image recognition, forward-looking camera systems that are coming out that start pre-warning you of objects in the distance, and can start calculating that a car is coming towards you at a set speed and it's time to take alternative action. So I think that technology is not really quite there yet, but we've been working in some ideas along that line. We know some others are working on it as well, and that technology to come. That I think is something I'd love to see in a car.
Similarly, my daughter just turned 16, so all these advanced safety systems would be really nice to have in the car now. But another interesting thing, I think heads-up displays combined with navigation. I'd really like to see an augmented reality kind of system where you look through your windshield and it looks like the path you're supposed to follow is painted onto the road. So really the combination of, in this case, a heads-up display and the navigation system linked together so you can, without having to look over there, get your guidance, and it's ideally would be painted on the road, but even just on the heads-up display would already be nice.
Are you finding the right skill sets coming out of schools? I can't imagine in the world of Facebook and Google that kids are waking up going, I want to be an automotive semiconductor engineer, right? It's just not sexy. However, it's we know it's going to be full employment for another 25 or 50 years. Are you finding the right skill sets, or is it a challenge?
I'd say it's we find the right skill sets. It's not always easy in all of the locations we try to do it. One of the things Peter was pointing out there is that we always have had a very significant international footprint. We always pride ourselves in being the most international of the automotive suppliers. A lot of the other guys are Japanese supplying to Japanese and Germans supplying to Germans, and we've always been very well spread across the world. So we have system engineering teams working in Munich, we have them working here in Austin, we have them in Japan, we have them in China. In the US, you're right, there's not the same number of fresh outs appearing wanting to be in the automotive market. But certainly in some of our growth markets like China and actually in Japan as well and in Germany, we managed to satisfy those people requirements very well. What
one market is emerging in automotive design that's going to surprise everybody in the next 5 years?
I think that from our perspective, it's got to be China. I mean, at the moment, most of the technology in China is driven from the large OEMs who are European or US OEMs who are building there, but you can really see the strength and the undercurrent of the Chinese own tier one electronics developers starting to grow. And the interesting thing is that some of them are already out and competing in the global market space just as well as they're competing in China. So I think you're going to see massive growth from those companies, and the level of technology is growing well. Some of them have done some excellent joint ventures with other technology partners in terms of like the module builders. So I think China is going to be the growth area. I think India will happen, but India will be a little bit later. It obviously doesn't quite have the infrastructure that helps it build an automotive electronics business at the moment. China to me is the place that's really going to boom.